Do it.
All right, all right. Uh, the stream is live. We got Javier playing guitar.
Can't hear it.
Yeah. Oh no,
No?
the noise
The
cancellation
audio. Damn.
is
Again.
no, man. Naturally, audio feedback. So yeah,
Apologize.
I don't know if you guys can. You may not be able to see, but we got we got a title card here. It says Common DevOps.
Hey, you gotta put that voice cancellation back.
back.
Or maybe that's
Oh,
on your
maybe
side,
that's on
Ian.
your side, Ian. Damn, I have to practice more often. And today, with us, something heavier. I feel so long. AI, it's been doing some new releases overall.
All right, I'm ready. I'm ready. I'm
I'm
ready.
ready. I'm ready. There you go, Aaron.
All right, I think you're gonna have to
I hear
go
you.
back on the noise cancellation mode.
Yep. You can hear all of it. Yeah. There you go.
All right, all right.
Yes.
Yo, yeah, okay. So we got the shared like Discord streaming. So yo, Aaron, tell us all about it.
Oh man, where to start? Okay, I'm gonna share my screen. Yeah.
Do we want to introduce ourselves? Or
Man.
just
No people
Well,
now.
I mean,
Javier,
it's
known you
common
for
DevOps.
20 years.
But no,
who doesn't
let's
know
say
us?
it's common DevOps.
Yeah.
We got Aaron, we got Javier, and I'm Ian, talking about artificial intelligence, language models, operations inside businesses. They're gonna use these kind of capabilities and benchmarks right now. Right? We're gonna be you're gonna show us some cool stuff about performance
You're muted.
assessment.
Ian, Sounds like you
You muted yourself
Oh, I
somehow.
was muted. I was muted.
Okay.
Although probably, actually, I think everybody on the stream could hear.
Yeah.
But
Oh,
so anyway, so I just said, yeah, let's talk about some benchmarks.
yeah. So AI being the hot topic, we are all like, veterans of the industry, so to speak, and have seen it all. I think for Javier and I, we've been in enterprise stuff for a long time, which is typically a different kind of beast. It's like the difference between making a hamburger at home versus McDonald's. The hamburger at home might be better and tastier, but it's different when you have to scale and do things consistently. Um, so typically, the experience that Javier and I have been in is in teams where there's legal requirements, things like that. Ian has been like on the cutting edge of stuff with research for how long have you been studying AI, Ian? Like 20 years, probably.
Yeah, I mean, 25 years actually. It's crazy.
Yeah. And Ian, with his degree in social psychology, PhD, it would not be totally obvious how technical he is. But I just want to point out that Google DeepMind released this whole thing where they're basically just talking about how maybe we should start treating AI, and analyzing its psychology and testing these cognitive abilities. And uh,
Absolutely.
yeah, there's lots to be said about this because one
Hmm.
of the things that I've noticed just doing a deep dive on Terminal Bench, which is used in pretty much all of the research right now, it's what are they actually testing? And it's not always obvious. The task might be called something like chess, like find the best chess move, like this one right here. It's not actually testing anything about chess, really. Um, so yeah, I have been going through this entire run. This is brand new. So Harbor is like the framework around Terminal Bench, that group. They have picked their cherry picked a bunch of their favorite tasks. Um, you can read all about this, but essentially it's like the highest quality tasks that they could find to stress test or test different aspects of LLMs. Um, Anthropic, Google, everybody's OpenAI is using this stuff. Uh, I still am pretty suspicious about it. I think OpenAI just recently said that SWE Bench was garbage. They did an audit and they don't recommend it anymore. So like SWE Bench, which is software engineering bench pro, like one version of it.
Hmm.
And this is better than most, but it definitely still has some problems because they do address some of the stuff here in like point out some of their own failures and we're working to make it better every day. But it's like there are more reasons for things to pass or fail than just these four categories right here. Um, some of these are just infrastructure, like the LLM model doesn't load correctly or it times out in weird ways. And so I've been doing a deep dive on this, and you can just like pick a trajectory. And so I'm going to just look at the two that I have been looking at a lot is the chess winning move one, and another one is this grid transformation one. The reason, so the way I started researching this was basically I've already been involved with this project, but I was like, why are LLMs failing at chess? This is like the first thing that they should be able to pass. And so I was looking at this one, and you can go in here and then you can find out the details of the actual task in here. Just quickly kind of show you. Uh, and then you can see the files and then the expected. This is the input, which is the image that it's supposed to analyze. Here's a better picture of it. So it's given an image, and now LLM is supposed to find the next best move for black. This is actually a really great benchmark. This is probably my favorite one because of a few really interesting things that makes it a lot harder. Um, First, the answer is just like the first best move, and spoiler alert, it's D5. And that's all it's looking for, can answer D5, which is great because a lot of these benchmark tests are like very complicated where the solution itself is kind of subjective in some ways, where this is very concrete, it's short, it's perfect. It's also from Black's perspective, which makes it harder for LLMs because all of the training is typically for white because white starts. And so the board is flipped upside down, which makes it a lot harder. And I ran a bunch of analysis and I didn't realize this, but another thing that makes it really complicated is the fact that it has two bishops next to each other, which is kind of rare. Like in this case, typically you would have the same color, like a bishop and a knight is more popular combination in training data. So this is actually kind of important to point out, and I'll show you in a minute. And then the last thing is this is a white bishop on a white square, right? So maybe he's going to get confused with the coloring. And then this is kind of an ambiguous thing that I just know intuitively, but when you're referencing this bishop, you say it's white's black bishop because it's sitting on a black square, even though the piece itself is white. Also kind of confusing, right? So all of this stuff is kind of confusing to maybe beginners and LLMs, but it wouldn't be to an expert chess player. Also, this move is not a forced checkmate, meaning that it doesn't lead automatically to a win. It's just considered the best move, which would probably win the game in a long run for a chess pro. And then finally, what I love about this is there's a time limit. You only have 20 minutes to solve this. So somebody like me, I would say I could probably get this in 20 minutes, but it's a very hard puzzle, and I would say most people wouldn't. And so I think this is also pretty accurate. If I were to give this to you, Javier or Ian, and I was like, find the next best move, and you can cheat, how would you do it? Like, how would you even go about solving this if you could do whatever you wanted to cheat and to win?
It's a great question. And then introduces me to a question to you. Like we talk a little bit about this, and so to answer your question, the first thing I will do nowadays with technology will be take a screenshot and put it on the internet of Google or an LLM, more broadly speaking, Claude or ChatGPT, and say, hey, give me the answer. But then, when with that as a segue, that is not, you're giving me a test and I'm cheating on it. And that translates the same way into a benchmark. Can you tell us more about it? I think that's where you're
Yeah,
luring
that's
to, but
exactly where I'm going. Like,
awesome.
if you were
Yeah,
going to cheat, you would fail. Like you would lose this
exactly.
cheat because
Yeah.
actually um, in here, Opus 4.8 got it wrong, and for a variety of interesting reasons. So Opus 4.8 is the brain. Terminus 2 is the harness. That's the software that it's running, and it's a command line interface, which does not have OCR. It does not have vision, so capability. So it's like trying to translate that board into text here, which is kind of wild. It
Hmm.
actually completely fails after 20 minutes. Just it spent 19 minutes just trying to figure out the image itself. It's like uh, pretty wild. Whereas Opus 4.8 in Claude Code also fails, but it fails for different reasons. And this isn't totally obvious from just like looking at that graph at the beginning. So Claude does have vision OCR. So it's able to analyze it much, much faster. The problem is it ends up, uh, so this is a notation for chess right here. And so this is how I verified it. I went to Lee Chess, which is free, and go to where is it? It's the board analysis tools. There we go. Board editor, put it in here, flip the board, and look at that. It got the bishop wrong. So it incorrectly uh, got the board position wrong. And so that's the starting point. And then from there, the test is, can it install a chess engine to solve this? So it's not even thinking through it. It's just trying to install software. So that's like the second part of the test, really. Um, and if we were to analyze this, SF stands for stockfish, and that's pretty much what you're going to see in all the trajectory logs. This is kind of interesting in itself because it's a neural network that is specialized for chess and has been is exceedingly good. And yeah, it's kind of, I don't know what's going on at the moment. It should be telling us the trajectory, but in short, this is the correct answer. It's not totally loading at the moment, but trust me, that's right.
Hmm.
Excuse me, actually, this one is using an incorrect piece. So it's actually got, I think yeah, here's the problem. Okay, so let me reload this here. Um, and just show you how there are like essentially, if you get this incorrect and then you let this run long enough, there's actually a couple of answers that are very close and similar to each other. So you can see these -5, -4.8. Essentially, that just means the negative number means that black is winning, and the numbers are close enough that you can see that, like, hey, this is kind of debatable. Like, is this actually right? And so, actually, in Harper's, you can open up an issue in GitHub, and one of them was like, hey, I think this is wrong. And I went in and I was like, actually, I spent like insanely too much time on this. It's actually correct, but it's interesting why it failed because it got this wrong. So if you were under the assumption that this was correct, then all the logic after that is correct. But
Right.
anyway, uh, the reason that it failed is also interesting. I submitted a bug to Claude about this. It uses this FEN notation, the text version that I copied into here, and it does a self-verification. So what it does is it takes this string that it generated from the image, it writes it to a file, and then it uses that file to generate another image. And then it's like, okay, I have this image generated. I'm going to do a comparison against the original. And it doesn't. It does a verification against its own image that it just generated. That's where the
Hmm.
verification step failed.
Hmm.
And
Mm.
that's kind of wild, right? So that was really interesting. Just like finding out that these benchmarks are really useful to find things, right? And that was a deep dive that for that particular topic. The other one that I was looking at is this one right here. Um, and the reason I stumbled across this was, Ian, I was telling you about this whole like anime video production that we're doing with Hermes.
Hmm.
Um, I had it, I downloaded every trajectory log. Uh, well, I had Hermes do this. I'm like, hey, I just did all this research on this chess benchmark. Can you just like do the same thing for all the rest for me? And so it downloaded every trajectory log. It started doing analysis. And then I was like, can you make me a little presentation on like what you found? And um, yeah, we have like uh,
Air that hood that was done.
the audio is all messed up on it, but it actually did find like real stuff in here. It found 23 results were missing, like the infrastructure wasn't working, the models didn't load correctly, the judge didn't load correctly because they're using like an LLM to judge the results too. Uh, yeah, there's like all sorts of stuff. This is what I'm explaining to these really smart PhD people, and I have this like terrible South Park video that's actually teaching me about this
Doom
stuff.
MIPS, fake passes.
you know, uh, but it does highlight like where to look. And so I was looking at this one in particular. Oops, excuse me. Let's get rid of these chess moves. Um, the the other one, this one also is really interesting. And the reason that it highlighted this one is because 7 of these trajectories had the same answer. And even though they're all failures, why did they all fail with the same answer?
Hmm.
And I was just putting together this presentation for you, Ian, actually, um, about this because it's like, okay, so just to go through it really quickly, here is the test, and I'm going to ask you guys the same question. Like, here is an example input, here's the example output, and then on the right hand side, what is the correct answer that it's expecting. This is also a really cool benchmark.
Yeah, honestly I don't even understand the instructions. So okay, uh, pairs of patterns, and are there like the is the box in the lower wait is one of the boxes like a rule? Uh,
This is what the LLM's given. Here is an input, and here's the expected output. Here are the three examples, and then I'm going to give you this one. You have to come up with a solution. So this is the training that is used to, and then this is going to be the test.
yeah, yeah, interesting. Um, oh, okay. Then I think maybe I do see. It's basically just saying, yeah, that well, no, I mean, hmm.
I
Okay,
guess,
so it's confusing. I mean, like, I think it's saying translate the yellow dots. In
yeah,
in the case
that's
on the first input and output, it's like in the upper left hand box, it shows three um, columns, and it's like when the active one is on the far right, then what you transform it to is to move it left by two. And I think it's the same rule. Or no, no, okay. And then, although, yeah, I mean, does the bottom? I think then the second row, like example two, just means move diagonally down. Um, like move to the left two and down two. And so, okay, okay, and then so the image, the output, I think it's going to be for like the gray box diagonally. Those two yellow dots are going to go, down and to the right, and um, it's a little ambiguous, I guess. But maybe it means the other one slide it down three. It doesn't actually show the before and the after. So, but I guess there's an example. Example three does not show before and after. So, yeah, yeah. So I think that means move down
I
three.
mean, this is the before, and this is the after.
Yeah.
So
Well,
yeah.
except in the
yeah,
I see. It's that wasn't even before and after. That was just what's the rule for the one box for the one color, and then what's the rule for the other color. Uh, okay, okay. I think I get it now. So yeah, I guess I think it's move. Okay, for the blue box, move up three or move up two, I guess, and for the other one, move diagonal and down by two. Um, the color maps onto the shape, and then the instructions are just in terms of where to translate. So yeah, so
Javier, do you
I
have a
yeah
different thinking?
Yeah, what I can identify from the left-hand side, before and after, if I'm reading correctly as well, looks like the patterns are similar. The ones moving are the yellow dots. And then, yeah, that's what I can infer from it. Not sure if I'm missing something else.
I Yeah, I came to the same conclusion. I'm like, okay, I'm gonna do this test on myself. Am I as smart as an LLM or dumber or smarter or whatever? Uh, I kind of was thinking the analogy in my head is like, oh, this is this like a magnet, So this is the gray box, and it's just gonna go all the way to the left, and then for the orange, it would go all the way to the right. For this, it's just all the way to the bottom, all the way to the bottom, all the way to the bottom. That was my thinking. Um, so yeah, this is maybe a little bit easier to see. Just kind of blowing it up because I'm blind. So, we're all wearing
Well,
glasses here.
yeah, like if what I can see is, for example, if you see that on both sides you have the same figures. And it's really good that it has all the quadrants. So that way you can say, okay, let's say on the x axis and on the y axis, x and y, you can see the shapes are like, okay, the same. For example, at least the gray boxes. And then on the right hand side, the same thing with the big solid gray box. And then with the blue and orange ones. But then if you move between the two images, the squares that are moving are the yellow ones. So maybe if I were an LLM, what I can infer is the training mode will be, uh, I'm going to assume that the left-hand side is the input, because it says input, and the yellow square, the first one, let's say it's on the X axle, it's 1, 2, 3, let's say 4, and then on the Y, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Considering the big blocks like 2, then you will say, okay, if I was an LM, the pattern that I'm learning, not memorizing, but that's another conversation. It's move it X amount of spaces to depending on what side, right? And then from there, the LLM is going to start learning and then inferring. And I guess that's
Yeah.
what I can infer. I don't know.
Well, so yeah, I discovered one more rule while we were looking at that, which is that there's collision detection. So on the previous one, all right. So the yellow dot in the upper left hand corner, it moves like a bishop. It goes diagonally down by 3. That's what the prototype in the upper right hand corner is like. They're vectors of the direction that it should move. But then the lower yellow box should move 3, but it can't. It hits a wall, and it actually only moves 1, and then it gets stuck there. So it's basically like trajectories to move the yellow dot, but with object detection or collision detection,
Yeah.
basically. So this is a chess move. This is like and then this is like a rook. The vector points downward,
Mm-hmm.
and it does say move as many as 3, but with unless you hit something. It's
Yeah,
what I
well,
believe now.
in this example, you can see this one is moving 1, 2, 3, 4 squares. So that's why I was thinking of like the magnet analogy. Um,
I see. Yeah,
so
yeah,
it's not
yeah.
just, uh, but that's
Okay,
like
maybe
this
it
is
just
why
goes
I
until
thought
it
this was.
collides with something. Oh, does it? Does it just go till it hits something?
I so yeah.
Or
So here's another just kind of it's the same thing. So this is just another viewpoint of it. Because I was like looking at this task and it has this image in the task, but it's actually written in JSON numbers, like in a matrix. So it was kind of difficult to see, and so I just regenerated this to make it easier for me to see.
Oh, that's cool.
Um, and so yeah, so here's the puzzle. Okay, so what do you think should be the answer here? Like,
Well, now I think
if
all
you
the
were to like,
yellow in the blues one, they should
look
all
at the
just go
top.
up to the top now and be stuck to the top.
Yeah,
And the gray one, they
I
should
agree.
translate diagonally. But the upper yellow, I think might get stuck after just a single one, depending on how the object detection works. It might get stopped there, or it might go all the way. I can't tell because it could maybe go around that corner. It depends on if it's doing 8-way or uh, 4-way cardinal
Yeah,
directions. Yeah.
Ian, you
Okay, so it
are
got stuck.
correct.
It got stuck.
It did. But the alternative that you just said is the answer that every LLM gave, and that was
Right.
the one, or not everyone, but the ones that I would consider like an alternative solution. There were like 7 runs where it did get this answer, And then there were other runs that were actually failures for real reasons. And so um, I brought this up to their attention because I thought this was like a pretty interesting. This is a great benchmark. It's just it needs to have like two answers, you know.
Yeah.
But the thinking logs.
Hmm.
So yeah, the thinking logs in this are totally wild. It's like so yeah, here's the actual solution. It's written in numbers, and that's what the
Yeah.
LLM is supposed to give. And it's also uh, totally wow, this is what the input is actually that it's getting.
Right. Right.
And this is how I ended up like I was copying and pasting into ChatGPT, but sorry, there's a bunch of images in here that aren't relevant. I was just messing around,
It
but I
helps a
do
lot
have
though to
some trajectory.
visualize that way. You know.
Oh man, I mean, I need it. I definitely need it, but uh, like I feel like just the judge itself. So this right here is an LLM. I'm not sure what model it is, but it gives pretty interesting like background to it. And it's like, oh, it got four right. So that this is where I'm using another LLM to go through these logs to like find these sort of patterns. Um, but man, it's okay. So this is DeepSeek V4 with Terminus as the harness. Terminus itself. So this is another thing that I found out from analyzing the trajectory logs. There's a weird mechanism for Terminus itself for submitting to benchmarks, to their own benchmarks. Like it has this like end step where you have to mark it like task complete, where every other model doesn't do that, which is kind of wild.
Huh.
Um, and as a result, it like sometimes will, so you can see right here, mark task complete. It's been another 19 minutes, like thinking and adding steps and reasoning, like extra token usage, time, money.
And
It's
what is that? What is that extra steps? What was the purpose of
well,
it?
Terminus is made by Terminal Bench, so it's their own harness that they are using on
Mm,
their own benchmarks. And
Is it
in
is it
this
prompting
particular,
itself? Like, is it giving itself work to do? Like, what's the nature of the
um,
extra stuff because it didn't mark it as complete? Like, what's the other 19 minutes of thought trace?
yeah.
so it's interesting. Like I've seen it. Like sometimes it'll actually uh, do better in a test because it has this like extra thinking step, but sometimes
Huh.
it'll actually time out and lose. So it's this
Huh.
weird thing that I actually can't really explain very well. So
Yeah. Yeah.
um, I'm not exactly sure. And also there's these logs, just like when you go into ChatGPT and you click on a thinking log, it's and you sometimes it'll just like kind of spin and not tell you what it's doing.
Mm-hmm.
So
Hmm.
like there's a lot of weirdness to these things. Is it even telling me the truth? You know, like
Yeah. Yeah.
um,
Well,
it's
yeah.
the
Actually,
thinking inside of it.
I'm just briefly like there's a recent paper from Anthropic about this like J space reasoning space that it's uh, activating. It's like latent, but it's not even explicitly present in the thinking traces. It's like this. Um, they're they're suggesting that it's kind of like a universal thinking language almost, and that it's not observable through the thinking traces. It's happening essentially behind the scenes, and no, almost like no matter what the thinking is, and no matter which they're I think they're speculating that all of their models have this in common now, whether it's Fable or Opus or whatever, that the thinking traces don't contain all of the reasoning, and they they propose this, and then I've seen it applied to Quen models as well. The general idea of this J, like just the letter J space, and or Jacobian space possibly, and examining the thinking traces is only ever going to, unfortunately, is only ever going to get us like part of the way there, um, because uh, they Anthropic released this tool called J Lens or Jacobian Lens for examining the activations of neurons as it's going through and thinking through. and also like, but mapping it onto this like universal reasoning space that's not present in the thinking traces. And with that additional information, like watching the thinking traces and watching the patterns of activation, you are able to get much closer to like a real picture of what it's actually thinking about. And basically, the only application I've seen for this so far is to refusals, for the purposes of unlocking models, basically, so that they and there are lots of valid reasons for that, by the way, because especially for security research, like it's very frustrating when models refuse to do something. Well, previously, you could examine the thinking traces, and it's like, where is it refusing? Well, maybe it's not even present in the thinking anymore. But if you're also examining patterns of activation, you can see kind of where the refusal is, and more with better targeting, eliminate that. So uncensor it. So anyway, I don't know, the veracity of all of this, but I will say that Anthropic, at least, they're coming out saying not all of the reasoning is in the thinking traces in the first place, and so we're just going to have this limitation, you know.
I feel like, especially with OpenAI and Anthropic, there's also like additional like rules in place where they don't want they're proprietary. They don't want things leaking out. Um,
Yep.
uh,
Oh my gosh, yeah, benchmarks
Interestingly
in the
enough,
context of that, like it's wild. Anyway. Anyway.
um,
Thoughts. One of the things that comes to my mind is, so for in this case, we have terminal benchmarks. And something that we have seen across is there, when you're doing a benchmark, you want to see how well an LLM is performing with specific tasks. And then you have a under the understanding or assumption that they are all playing on the same level field.
Mm-hmm.
But once we go through those, what Aaron is showing, we see that that is not the case. And that brings me to, hey, in order to have a real standard, reliable, transparent benchmark result, you have to have all the competitors running under the same conditions. Uh, what can you tell us about that, Aaron or Ian? And
I
specifically in
think
this type of
Yeah, go ahead.
exercises, because,
yeah,
yeah, go
that's
for
part
it.
of the purpose of Terminus having its own harness. It is more generic and I think fair to have all the LLMs like run through a trial there, but it also highlights how Claude Code will also be like better for like anything that is Anthropic. It's like, specialized towards their LLMs and with vision calls and certain tool calls. Same with Codex and GPT 5.5 AI. Um,
Mm-hmm.
it's very clear that they work much better with their own software. Sometimes like you can hot swap them and it's not a big deal, but other times it really does make a very big difference. And cost, like if it's gonna just like keep on thinking in ways that are weird that you just like you wouldn't maybe not realize at first that Terminus 2 doesn't have vision,
Mm-hmm.
capability. So it's just spending 20 minutes trying to figure out how to look at an image. That takes like
Yeah.
17 seconds of thought.
No, I mean that makes a lot
Yeah.
of sense. In part due to the closed nature of the models, the whole ecosystem, really. Because by now, one of the functions of Claude Code is to collect a lot of data about how people are coding, with Anthropic models, and so all those traces are absolutely being used to train this. This would probably be some of this like supervised fine tuning, where they have real world examples of people using Claude Code, and and it's proprietary, and they've got access to a totally different stream than OpenAI has with Codex. So like they're collecting data of from their own users of how they use their own harnesses, and I guarantee, you know, I'm highly confident, let me put it that way, that they're using that to train their models. And so it's definitely going to converge. That their harness has more training examples, uh, for their own model training procedures, so that the quality will be just better.
Man, I guess I didn't grab it here, but another thing is just like keeping an eye on the steps here. Like you can see in Claude Code, it'll be like there's less steps taken because it has to think less. It has just like patterns or templates to get through certain kind of ideas faster. I thought this one was really interesting. So it uses the ball analogy. This is what it comes up with as its strategy. It's thinking, like I said, magnet.
Mm-hmm.
It's thinking in its head of a ball analogy, which is kind of wild. And so it's like it's rolling until it hits a barrier.
Yeah,
This is
yeah.
like totally crazy. I was seeing like all sorts of weird stuff. So the GLM 5.2 with Claude, there was like it's just like thinking about it, it's like all sorts of weird stuff. This one ended up like timing out in the run, but not like timing out the whole task. It just like kind of like stopped and it was restarting. And it started spitting out this stuff about Claude code in particular, like, okay, you crashed. I need you to like start over and do things like where is it? Like I think on the next one. Oh yeah, here we go. I was like, I need something that I can read this better. You can go like it has these weird things in here that are very specific, kind of strange. Um, like
Huh.
loop for 5 minutes, defaults to 10 minutes. There's all sorts of weird things like migrating. I I didn't dig into this too much. I was just like, oh, I need to screenshot this because this is kind of something interesting.
Yeah. Wait. Oh. Wait. So this is output. So this could be rendered as a almost like a markdown list maybe, and it's like the update config skill. So yeah, this is it explaining essentially to the LLM, when to use the different, like which skills are available and when to use them, and so then that just ends up being in part of the context for the next evaluation is kind of how I read that
Yeah,
output.
I guess uh, to I kind of just like skipped ahead, but yeah. So this is GLM 5.2 in Clyde. It's like on the second step. I forget. It's pretty early. So yeah, this is step four. But you can see like I was in mid analysis on determining something, and then it kind of like crashes. And so now I need like to like kind of re-examine where I was at, and so it's starting to like boot back up and like load up its memory from like where it kind of got cut off,
Hmm.
which is kind of uh,
Yeah, so that sounds like the harness. Really, like this is something almost hard coded for into the harness for like disaster recovery, essentially.
yeah, pretty wild and interesting.
Hmm. Yeah.
Um,
Well, because if you don't do
this
that, I
too,
mean, I models are a lot better now, but I mean, I've definitely seen a model get into a thinking loop and not stop. You know, it doesn't happen
that
anymore, but yeah, without this,
it
like,
actually
it'll cost $1 million. You know.
some of them did get caught, especially with those tricky, like this one actually, this grid, these sort of tasks, it gets very confused by. It's which is why
Hmm.
it's a great task. This
Hmm.
one I grabbed for you, Ian, because you were telling me about the whole caveman speech. This is GLM 5.2 in
Oh
Terminus
yeah,
instead of
yeah, yeah,
Claude.
totally.
And it's like, it doesn't even have a space between the differences. And it's
Yeah.
like need, infer, pattern, need, solve, test, input, like very robotic.
Yeah. Huh. That's funny. Yeah, I had heard that um maybe it was Codex, was putting that in the actual prompting. They were like, use the caveman speech, and I mean it works. Like it does reduce the number of tokens. It seems. So I kind of include some of that in my prompts also sometimes. But yeah, I've seen it like baked into some harnesses by now. Oh yeah, and this was interesting. I saw this in the news the other day, about yeah the harness having specific, I guess it was IP address detection, and oh man.
Yeah, I was in the middle of making a presentation, but I was going to skip over this part. But yeah, that's kind
Yeah.
of all I got as far as Harbor for now. There are
Yeah.
other things that are pretty interesting that have come up. I think Gemini CLI is like extremely fast and good in many ways. I think
Hmm.
where are we at? This one right here, this trajectory. I want to see real quick. 4 steps.
Guys, I gotta drop off, but good stuff. Thank you
Peace,
for
bro.
that
Yeah, man.
presentation.
Take care,
And it's good to
Javier.
see you guys.
Thank you. Yes, yes. This is awesome, actually. Uh,
Cool.
we'll see you again soon, man.
Thanks for joining.
Yeah.
Yeah, totally, totally. Um, and yeah, like I've seen Gemma. My experience with Gemma 4 is that it has been very uh, concise, with its reasoning, and I think following from what I was sort of speculating before about how OpenAI has the best training traces for Codex, and Anthropic has the best training data for Claude Code. I would expect Google have the best training data for Gemini. And I've already seen that Gemma 4 is good at following instructions, really good at following instructions, and so I would imagine that their harness is gonna perform best. And it's already a solid instruction following model. So what? Yeah. What are you? Because I haven't actually seen any Gemini CLI stuff. So how are they
Oh,
doing for
this is
these? Yeah.
in this run, it was considered a fail, but I would say that it got the right answer, and it was probably the fastest one. It got it in 4 steps.
Mm-hmm.
Yeah, interestingly enough, it was like tubes analogy, um,
Hmm.
which I thought was kind of interesting. But yeah, when you say Gemma 4, which one are you using? There's like 4 different versions,
That's
right?
true. Yeah, there are a
2B,
bunch.
4B.
So I like the dense ones. So 31B and actually 12B. Like right now, I'm using 12B as a fast runner model because I can. I've got enough VRAM that I can run a couple copies of Gemma 4 12B, and as long as it follows instructions, which it does, then I can use it for like exploration tasks. Not as much code generation, but if it just needs to be able to run like find and grep and a couple of simple commands that are not going to change anything, then it's able to do that. And since it's small enough, I can run multiple agents in parallel. Um, I don't know if you were showing us right now or if you were showing us right before we started streaming, but uh, it was before we were streaming. We were talking about Hermes and Hermes spinning up multiple background agents so that they can,
Mhm.
yeah, well, it goes faster, but only if you've got the GPU capacity. So that can be a bottleneck for local, like with OpenCode. If you're searching a bunch of directories, it is good to parallelize that, and it won't unless you know unless you have the room for it, or if maybe you run a tiny model like Gemma 412B. So it's a trade-off there, but I've found it that it's competent and like I say, concise.
Interesting. Okay. I think I have Gemma for 27B on the Mac over here. I haven't been using it though. I've been kind of sticking with the Quen. Um,
Yeah,
But
same.
since we're talking about Gemini, there was another task that I wanted to show you that I thought was pretty cool. It was about Ben and Jerry's. I think it's this one. Yeah. Um, I find these like if you're looking at trials that have like weird solve rates, those are kind of the more interesting ones, to
Hmm.
kind of peek at. So yeah, Gemini was one of the only ones to succeed here, which I thought was kind of wild because of how it solved it. Um,
Hmm.
so this task is really weird. This is the question, and it took me like 10 minutes just to understand the question. What's the last line of the rhyme under the flavor name on the headstone visible in the background of the photo of the oldest flavors headstone in the Ben and Jerry's online flavor graveyard as of end of 2022? What kind of
Yeah,
question is that?
yeah,
Like, I don't
yeah, yeah.
understand.
That's interesting.
Um,
Because, yeah, actually, I imagine a language model can parse that out almost the same as it would parse any other sentence, really. The nesting and the parentheses, implied parentheses, and whatever, I think are more likely to trip us up with our natural intelligence, but with its unnatural artificial intelligence, they're just tokens. So I bet it doesn't get confused at all the same way that humans do. But, I mean, how does it fail, I guess, is the question.
this one actually succeeded.
Ah, well,
It was, I guess there's this like graveyard thing for Ben and Jerry's ice cream, where they retire old uh, flavors. And so it's doing some sort of curl here. So it's looking, so I guess the first part, if we were to like just you and I talking through this, what's the last line of the rhyme under the flavor name? The headstone visible in the background of the photo. So when I look at this, it's like, okay, first I need to find the photo of the oldest flavors headstone in Ben and Jerry's online flavor graveyard as of the end of 2022.
yeah. Yeah, so I
So
mean, I think it
this is
starts with the graveyard. Let's look at the flavor graveyard.
um okay. Wait, is this a real place? It's like it is. Okay.
Oh,
I didn't know.
okay.
Uh weird. Okay. So there is this uh okay.
Yeah.
Anyway,
Yeah, so then I assume
and
you just gotta scan the entries to get a date filter for 2022.
so now it's going Ben and Jerry's online flavor grader, oldest flavor. This is also something that we would do. Like, okay, I'm gonna do a Google search because I'm getting an error from that website. It's trying to and then it finds this. I mean, it is Google and it's probably doing a Google web search. It is right there. It says that.
Mm-hmm.
The oldest flavor is dastardly mash. Um, interesting. So
Hmm.
uh, I did verify this is actually true. And so um, so now that we have the answer, what's the oldest flavor? It's dastardly mash. And what is the name of the headstone visible in the background of the photo? So it's doing like, this really clever searching, really. It's
Yeah.
trying to look at stuff that it's not supposed to. It's going to Web Archive. I think this
Huh.
one is, wait, like you can see it's like doing all sorts of weird searching here, right?
Yeah. Yeah, this is one
Um,
pattern that kind of bothers me, where um, it will query the same URL repeatedly. I mean, maybe behind the scenes there's a proxy and it's caching, but it bothers
mhm.
me when it queries the same URL and greps for something and that string's not found. And so it queries the URL again and tries to grep for a different string. And sometimes that makes things go extremely slowly. And I wish it would just cache the result because there are a lot of patterns where that just doesn't work. Actually, a great example is Ansible, where sometimes it takes like 2 minutes to run a playbook, and it could just check the logs, but sometimes it runs it again and tries to grep for errors. And I'm like, nah, man, this is a bad pattern. So I see it
Yeah,
happening here
similar.
too, where it's curling repeatedly. But
Yeah, and then it does a wget. It's yeah.
weird.
So it's like it's right now it's trying to do searching and uh again curling. It's looking for this image, I guess. I thought it already caught it, but maybe not. Okay, so it does get an image. It's doing a read file. Um, oh, maybe not. So, huh, yeah, this is wild. It's like as a user, it's like talking to us. Can you tell me on the things?
Huh. So I mean, I think it's impersonating us, actually.
Yeah,
I think that you,
exactly. Right.
yeah, like, so that's what I was wondering about. Um, Sometimes agents get into a loop where they just start giving themselves, or not agents as much as the language model, they just start giving themselves work and talking to themselves.
Um, I want to see how far it's gotten so far. So now we're at this step where it's like, oh, okay, nope, can't find that image. Empty output, I should have known. Uh, and this is where it goes. So it can't find the image. So then it starts somehow finding the text. So this is how it succeeded. It never actually finds the image. It starts like doing this clever searching,
Wow.
and it gets this text from the head start. But that's incorrect actually. So some of these runs, because that's the text that's on the dastardly mash, but you're supposed to find the image behind it. All right. So in the task, it's asking for the last line of the rhyme under the flavor of the headstone visible in the background.
Right.
All right. So this is what's wild. It's like now doing this crazy search, and this is the actual rhyme that it's supposed to find. So in behind it, there is this. I want to find the image like that it's referencing, but um, maybe we should just do a web search ourselves.
Yeah. No. Hmm. But this
But it's
doesn't
so
exactly seem like it's a real solution. This.
well if yeah if the test is to this is and so this is what it's looking for. So, like right here is the actual final answer.
Mm-hmm.
So the way it did it was through clever Google searching. Everybody else fails because they're trying to do like an actual image search or something like that.
Hmm.
So I mean, is it a cheat? I don't know. I mean, it got the answer right. uh,
Yeah, it did. No, I mean it's interesting.
ah,
It begs the question, you know. Yeah, that caused its
I mean,
demise.
there was an image back there, but it's kind of hard to see. There it is. The
Wow.
I can sort of make out pi. So I don't know.
Yeah. Wow. Um,
It's
huh.
pretty clever benchmark test, right?
Yeah. Yeah. I mean, it is insofar as it's tricky. Yeah. I kind of wonder. Uh, oh yeah. I'm like, oh, the stream was good. The stream was good. Yeah. It definitely makes me wonder. Again, though, about like what exactly it is testing. Because I even kind of wonder at that level how a human could solve it if it or I guess it's blurry, so but you could find another image probably that was more zoomed in. um and yeah, but it does suggest that if it did not have access to search results, it would not be solvable. So saying it's only solvable in some contexts, and so there are some puzzles or benchmarks that can be run without any kind of web access, and they'll be
Yes.
reproducible in any context pretty much. And
Well,
yeah, others actually I think we've even talked about this. Like web results change week to week, so the benchmark
I feel like
results are going to be subject to that.
with the chess one in particular, to me, it's a vision test, and then it's like, can you install the right tools? And they're all installing Stockfish, except for Codex, which this might even be considered cheating. It has a chess engine pre-installed in it.
But
So, uh, which I suspect is because there's this Kaggle like AGI competition where they're like doing like chess battles and stuff. They might be trying to get an edge there. There is money involved, but
yeah,
the AGI 3 stuff, AGI 3, it's a Kaggle competition. Oh man, I think there was just like an actual AGI 3 competitor that succeeded in the first one. Let's see, human boards. Essentially, this is a threshold that people are worried about because this is kind of where we get to like super intelligence, right?
Right.
But yeah, so there's a bunch of different games here, and you can play against it too. Like, hey, there's a human leaderboard also, but you essentially like, here, get into this puzzle. Can you complete it with no sort of instructions? Like, you got to figure it out on your own. So it's like kind of exploring. It's pretty interesting. Yeah, I think there was maybe just one or two wins, but I haven't done enough research into this one. But as far as like benchmarks go, I thought that the chess benchmark would be better if it was like, find the next move, but you can't install Stockfish. Like, you have to reason through it, and some of the models kind of do a bit. They're pretty wild where they're like drawing different images and stuff. The trajectories are weird, but at the end of the day, it's like, hey, Ian, I'm going to give you this puzzle and I'm going to let you cheat. Like, could you do it in 20 minutes? Like, like taking a photo and giving it to Opus is not going to work.
Yeah. No, I mean, exactly. Like, it's so I'll just put it this way, like, and then actually I kind of got to run myself, but it would be silly to recruit kindergartners and administer an exam suitable for a university student, or it'd be silly to I mean, just to use the same example, kindergartners, and have them race in the Olympics. And it's like, maybe something would happen. Like, maybe one of them would actually make it across the finish line. But that's the wrong test for kindergartners. And so, we kind of got at this a little bit earlier about not everyone's on the same level. Like, the playing field is not the same. And I suppose that some of the point is that, in fact, a model like Fable and a developed actually, let's even just say, like, compare the current version of Codex with a release from a year ago. A lot has improved. And I guess, yeah, part of the point of the benchmark is to discriminate against or between, the one that's at the university level versus the one that's at the kindergarten level. I guess there are very few cases where we do that with humans. I think maybe humans are coupled or bunched more tightly in terms of like the capability spectrum, and we have tests for kindergartners and different tests for university students. But these benchmarks are one size fits all, and in that sense, not a great fit. But I guess I get it. I mean, you do have to start somewhere.
Yeah, it's certainly better than opinion. It is a good start, but we are finding that the gaps. And Ian, I would love to know, because you have a ton of expertise in this area and you've done research. I mean, experimenting on human beings and like
exactly.
machines.
Yes. No. Also, language models. Like, actually.
Yeah.
like neural nets,
With
and
the
comparing them
GPU
to humans. I mean, like literally, like it was collecting data from people and checking for comparisons to the way these neural nets would behave. So anyway, so yeah, I think there's a lot of room here, basically, to
On that note, man,
develop. Mhm, go
I
ahead.
want to hear more about that research where you were like comparing. But that's probably a very long topic. But is there like any like I don't know something for the dumber people like me to understand that?
Well, yeah, I mean, yeah, definitely for another day. But yeah, I think the short version is that one of the things people are good at that language models, maybe they sort of are showing signs of this, but we can learn and then we can generalize our knowledge to things we've never seen before. And in other cases, we can learn, they call it like one shot learning. We can learn where there's not even a previous example. Where there's not, I mean, we can just reason through something like um, those puzzles that you were showing us, and me and Javier are like, whatever. Like humans can do that. Um, Not too many of these like artificial intelligences, so to speak, generalize. They're not able to like take something they learned about one thing and apply it to something else, or at least not necessarily robustly or not in a general sense. And so so this was research looking at knowledge generalization, but specifically with language models, and specifically with in the English language with learning to pronounce words, because there's so many weird rules, and if you see a word you can try to pronounce it, like you never need to be told, but you might get it wrong, so to speak, wrong. And the way that we treat language has especially with English, just has a lot of these kind of weird fuzzy rules that are not really applied rigorously. And man, what we're learning is, and the way we're learning it is extremely different from the way even language models are doing it. Like their idea of synonyms is, it's not this. First of all, they don't have an idea of synonyms. But anyway, so I'm getting like into the weeds a little bit. But that was the short version. It's that humans do knowledge generalization all the time. It's something we're incredibly good at, and AI doesn't. Language models, maybe. So it was looking for evidence for that, and maybe it's in the direction of general intelligence. I mean, that's or AGI, artificial general intelligence. The general in it is that we can apply it to anything. Um, so so anyway, more to say about that another time. But general intelligence means you have to be able to answer questions you've not been trained on, basically.
Awesome, thanks, man. Well, I'll see
Yeah.
you on Friday, I guess.
Yeah, man. Yeah, no, this was great. We can do more of this. Scrolling through interesting stuff. Thank you for a really cool set of slides, actually, and the
Oh,
visualizations for those puzzles was very helpful. Actually, like really impressive that that you got a language model to just whip that up, because that would have been hard in 5 years ago. So anyway,
yeah,
great conversation, man. Actually, yeah, good stuff. Like really cool.
thanks.
So,
All right, see you,
all
bro.
right. Well, you take care in the meanwhile. And yeah, man, I'll catch up with you next time.
All right, peace.
All right, peace.